Welcome students. Let us continue our discussion on the topic collision. In the previous class we have seen the problems on direct impact. Today let us start with the problems on oblique impact. Oblique impact, as you all know, we have seen this, that when the velocities of the body A and body B are not along the line of impact, then it will be known as the oblique impact. Now the thing which we have to remember in this is the velocity in the direction perpendicular to the line of action remains same before and after impact. What does it mean? Now let us say our line of impact is along x-axis as shown in this figure. Now as per this statement, the velocity in the direction perpendicular to the line of action. So if line of action is along x, the perpendicular will be along y direction. Remains same before and after impact. That means the velocities in y direction, the velocities of both the balls in y direction will be same before and after impact. So if I consider the case like this, when the line of impact is along x-axis, here I will say that velocities along y direction will be same before and after impact. Similarly, if I consider the impact like this, wherein the line of impact is along y-axis, then I will say that velocity along x direction will remain same before and after impact. Okay, now let us solve some problems based on this. The next question is, two smooth balls collide as shown. If MA is equal to 1 kg, MB is equal to 2 kg, E is 0.5, find velocities after impact. Now you see here in the diagram, both the velocities of ball A and ball B are inclined and are not in the line of impact. That means it is a case of oblique impact. So this is my line of impact. Now we have seen that the velocities in the direction perpendicular to the line of impact always remains same. That means velocity in y direction before impact and velocity in y direction after impact will be same. Proceeding with the solution, here the velocities are inclined at some angle. So as the velocities are inclined, we need to resolve it into two components in x and y. So it will be this. So this will be 3 cos 30 and this component will be 3 sin 30. Similarly here, we will resolve it because it is inclined. So this will be 1 sin 45 and this will be 1 cos 45. Now, as the velocities are in both direction, I have to apply impulse momentum equation in both direction. Let us start with impulse momentum in x direction. So I will write initial momentum is equal to final momentum, but remember that I am now applying impulse momentum in x direction. That means I will consider velocities only in x direction now. That's why I have written here also MAUAX, because I am considering velocity in x direction only. MBUBX is equal to MAVAX plus MBVBX. Now in this equation, the things known to me are MA, UAX, that means initial velocity of A in x direction. So it is given to us as 3 cos 30. MB given to us as 2 kg in the equation. UVX, that means initial velocity of B in x direction. So initial velocity of B in x direction is 1 cos 45, but as it is going towards left side, it will be minus 1 cos 45. Then MAVAX, final velocity in x direction. This is not given to us, let it be as it is. Similarly, VBX is final velocity of B in x direction. This is also known to us, let it be as it is. Substituting the known values, I will get one equation as VAX plus 2VBX is equal to 1.18. Let this be equation number 1. Now also we are given the value of E. So I will apply the formula for E as E is equal to VBX minus VAX divided by UAX minus UBX. Because I am applying impulse momentum equation in x direction, I have written here VBX, VAX, UAX and UBX respectively. Substituting the known values, I will get another equation as VBX minus VAX is equal to 1.65. Let this be equation number 2. Now, from equation 1 and 2, there are two unknowns which are VAX and VBX. So So solving these two equations simultaneously, I will get the answer for Vax as 0.706 in negative and Vb as 0.94 meter per second. So by this, what we have done, we have just found out the final velocities after impact in x direction only, but this was not required. The thing required in the question was find velocity after impact. This means we have to find out what is the resultant velocity. So we have just now found out only velocities in x. Now we will apply the similar procedure in y direction and we will get the answer for Vay and Vby respectively. So let us start with that. Now before that, let us recall our statement which we have discussed few moments earlier, which was the velocities in the direction perpendicular to the line of action remains same before and after impact. Hence I can write Uay is equal to Vay. This is initial velocity, this is final velocity, both will be same in the direction perpendicular to the line of action, that means y direction. Similarly, I can write Uby is equal to Vby. Again with the same concept that velocity in the direction perpendicular to the line of action remains same before and after impact. So with this I can write Vay I can write as is equal to Uay, which was given to us as 3 sin 30. On solving which I will get answer as 1.5 meter per second. For Vby I can write Vby is equal to Uby, and initial velocity in y direction was given to us 1 sin 45, but as it is going towards downside it will be minus. So I will write here minus 1 sin 45, which I will get as minus 0.707 meter per second. So these are the answers for velocities after impact in y direction. In previous case we have found out velocities of A and B in x direction as minus 0.706 meter per second and Vbx as 0.94 meter per second. Now we have velocity of A in x direction, we have velocity of A in y direction. Now we need resultant velocity. So we have a formula for resultant velocity as Va is equal to root of Vax square plus Vay square. So on solving this, I will get answer for Va as 1.65 meter per second. Now as velocity is vector quantity, along with magnitude we also need the direction. So for direction we have theta is equal to tan inverse of Vay by Vax. On substituting the required values, I will get the answer for theta as 64.79 degrees. This thing we have done for finding out velocity of ball A. Similarly for ball B, I will write Vb is equal to root of Vbx square plus Vby square. Substituting the values, I will get 0.94 square plus minus 0.707 square. On solving this equation, I will get answer for Vb as 1.176 meter per second, and theta I will get Vby by Vbx. On substituting the values, I will get answer for theta as 36.95 degrees. So with this we have found out velocities of both the balls after impact, which was asked in the question. Thank you.